Welcome to That Engineered channel. My name is Nathan, and I'm going to be showing you the process that I'm using to come up with the parts combination for my new truck that I recently got, 99 Dodge Dakota RT. This is my first video, so we'll just see how it goes. Please like and subscribe, and any comments, feedback's appreciated. So let's go. And welcome to my virtual dyno room. So recently I have purchased a 1999 RT and I want to do some heads cam modifications to it. And to make sure I pick out the right combination, I like to take a practical approach and have actual data to back up my combination as opposed to just hey, use this or use that. It works, whatever. I want to make sure that everything works together. I can get the most bang for my buck. A lot of people don't believe in DynoSim software or desktop Dyno, I think was an older one. But um, I have found that if you use it correctly, it can be very accurate. So I wanted to show how accurate it can be if used properly. And this is going to be my, starting point for my build, and then we'll make modifications to see what combination and what kind of power I can make, and then ultimately you can see what it might run at a track. So this is DynoSim 6. Um, I guess it's the recent version of the DynoSim series. So I got to come in here and actually do extended converge. So I wanted to try to be as accurate as possible, and I want to do RPM steps of 200. It's, up to other people. A good start RPM 2,500. We don't need to go up to 8,500. These motors don't really like to spin too high. I'm just going to call it 6,500 for the stock motor, short block. So luckily, DynoSim has quite a few uh, engine born stroke configurations already in here. So it's a 5.9 RT. So we're going to go with the 360 V8. It plugs in everything. You can see uh, the uh, short block information there. So in cylinder head. So I pulled go in and I've actually compiled a lot of cylinder head data. Especially there's a Stan Weiss website page. He's got head flow information for practically, almost every vehicle out there. So it is a very good source. So come in here and then let's just choose the 360 stock head. Okay, so it imports the flow numbers. These are the flow numbers that I had access to on the Stan Weiss website, and they seem to be backed up in some other places as well. So then you're going to go click OK. Then you need to come in here and actually show what intake and exhaust valve. All right, then we move on to induction. So this is one of the areas where it's it's you know not a perfect match for everything because you don't know some of the actual dimensions of the runners and everything. So you have to kind of get this dialed in uh, based on some other models that I've done before. I've kind of figured out which works best with different applications. So you come in here and click on, this baseline worked pretty good for some stuff, but this I have found for the stock Kegger manifold, the this domestic dual plane high torque restrictive, it's pretty good. And then a lot of times, if you go with the 2.5 degrees of angle taper, um, it's a pretty good, just medium point. Just keep a note that, you know, this is the probably the one area, the intake manifold and actually your exhaust, to where it's the least amount of solid information is. So it takes a little bit of practice to nail these areas down. So then total airflow through the throttle body. So you can, there are two ways of doing this. You can come in here, put in your throttle body bore diameter, and it will actually calculate the flow for you. But the twin throttle body for a stock Magnum is about 640 CFM, and then uh, you come down here to the camshaft information. Now, sometimes it's a little bit hard to get a hold of actual factory camshaft specs. It's kind of hit or miss. So the specs that I have found, to the best of my knowledge, um, are in here in a file that I have saved previously. So it's going to be the stock 360 truck cam. So it's a pretty puny cam by today's standards and everything. So um, not a whole lot of lift, whole lot of duration. And that's why these things are just a lot of torque, low end, and then it just fades away. As you get to the top end. So note here though, so I'm on right now. I really only care about true valve lift, and there's a quirk with the software where it automatically changes up your rocker ratio. Used to, you could actually input a valve lift height in that 10-point cam manager, but they took that away. So it's always going to default to 1.5 rocker ratio, and it will adjust the cam lobe lift accordingly. I don't, I've done some sensitivity checks of it. It doesn't really matter as long as your actual valve lift is correct. That's all that matters. So then you can see all the timing events in here. Now keep in mind there's some assumptions based on where the actual center line is on these. So there could be some variations from there as well. So you can go in here, you can go into your combustion chamber. So two ways to do it. You can come in here. I've done this before. Figure out all your different gasket size, chamber size, and everything, and it will calculate your compression ratio for you. We know that Magnums, the 360s, were essentially like 9-to-1, give or take a little bit. Some might be less, some might be more. And we're going to go with just basic pump gas. It's going to default to a standard air fuel ratio of 12.5, and it gives you different options here for um, fill types and stuff. So that's very handy. And moving on down here to the cylinder head, the top of got, it's actually going to be a wedge closed fast burn head. And there's two ways you can do the timing on it. You can leave this box checked. It will estimate, it's going to give you the best timing to get maximum torque everywhere. It doesn't, if you try to do it manually, you can't really modify the curve too much. So for all intents and purposes, I use the timing curve that's going to, give it the most power, even though the factory tune, they might, take that away a little bit. So you come in here, last piece is the exhaust manifold. So for a factory one, you can go either ways. I know some of the uh, dynos, like Richard Holdner's dynos, he, my times it's going to be without cats and, no mufflers. So, but, so instead of the stock manifolds, we'll go HP manifolds without cats. And then down here, you can really just tune it. You can't really in Dyno Sim 6, you can't individually modify these pipe diameters or anything individually, so you can only kind of input it by an RPM. So since it's a manifold, the runners are essentially no runners at all. They're just the very short, log style manifolds. So you set that to 20,000. It's going to give you the shortest runner length there. So in and come over here to our set up our ranges here. So I want to do a mid range for the x-axis, and for the torque and horsepower, I like to give it a custom range just so that way make the curves a little bit larger. So let's go from, we'll call it 100 to, let's just say 500. And let's do the same for torque. Yeah, apply. So we can also probably just pull the RPM down to say 7,000, just to give us a little bit better view. So there you go. That is roughly what a stock 5.9 liter Magnum came from the factory with. So, see it's real torquey up top, and, you know, horsepower peaks, a little over, about 4,800, I think, what they advertised. It comes up, so it's pretty close there. Um, and let's see, let's actually do a start RPM a little bit lower and see what it shows us at, say, 2,000. Yeah. But anyway, so if you want to save this, so save as. So I've already got several different configurations. So let's do um, uh, 360 or video. All right. So there you have it, folks. There is modeling it in DynoSim. Now that we've got the engine curve from DynoSim, we can see what it does at the track as a form of validation. So I won't go all the specifics and bore everybody with the setup, but you can put in some vehicle information, engine stuff, got transmissions, wheels, tires, driving style, weather for your track conditions, and you import a engine curve, boom, and this one pops up for these conditions. It run at 15.1. I got the weight of a club cab too. Keep in mind, so 15.1 at 90.4 miles an hour, 8 mile and 9.68, roughly 9.7. So that recalls um, about what they ran back in the day if they were stock. Because I remember when I had my 92 regular cab Dakota with a 318 in it with the a few mods and stuff. I was running 920s in the 8 mile, so that sounds about right. So that's one way to validate it. And here is the validation. So as you can see, mine is the green line. Blue lines are Richard Holdner's dyno results that I took and put into Excel, so that way I could overlay it with my dyno sim results. See a pretty close match there, a little bit off in the torque. That maybe has to do with the intake manifold that I'm using. But overall, I'd say that this is pretty accurate. I might even model a couple more of the combinations that he did in some of his other videos. But the next step is to start changing up the cylinder heads, camshaft, and everything to see what part that I want to use for my engine. And here's the beauty that I will be doing this work on. So everybody, please like, subscribe, share this video, share the channel to as many people as possible, get the word out, try to get some views on this video. I'll be doing more. If anybody wants to see more simulations of different engines, just put in a comment, and I welcome any feedback. Anybody, if anybody has it. So, yeah, and this will be it for this video. See you on the next one.